अस्सलाम वालेकुम स्टूडेंट्स, क्या हाल है। अच्छा, अपने सिलसिले को आगे बढ़ाते हैं और आज हम फिज़िक्स नाइन्थ क्लास के यूनिट नंबर 2 काइनेमेटिक्स के नेक्स्ट न्यूमेरिकल्स प्रॉब्लम जो है वो डिस्कस करते हैं। और उम्मीद करता हूँ कि आप लोग सब ठीक ठाक होंगे और पिछले न्यूमेरिकल प्रॉब्लम्स में अगर कोई भी प्रॉब्लम है तो वो आप लोग कमेंट करके मेरे साथ डिस्कस कर सकते हैं उस वीडियो के नीचे। लास्ट वीडियो में हमने 2.6 तक जो न्यूमेरिकल प्रॉब्लम थे वो डिस्कस किए थे। अब हम 2.7 को डिस्कस करेंगे और इसमें कैसे इसको सॉल्व करना है वो देखते हैं। इसकी सबसे पहले स्टेटमेंट हम पढ़ते हैं। स्टेटमेंट में इसके तीन पार्ट जो हैं वो डिस्कस किए गए हैं। तो मैं आपको पार्ट वाइज जो है वो इसको एक्सप्लेन करता हूँ। अ ट्रेन स्टार्टिंग फ्रॉम रेस्ट। एक ट्रेन जो है वो रेस्ट मींस के वी आई जो है उसकी ज़ीरो है, वहाँ से मूव करती है, एक्सलरेट यूनिफॉर्मली एंड देन इट अटेन्स अ वेलोसिटी ऑफ 48 किलोमीटर पर आवर। 48 किलोमीटर पर आवर जो इसकी वेलोसिटी है, इसको हम वी एफ कंसिडर करेंगे इसमें और इसको कन्वर्ट करेंगे मीटर पर सेकंड में in 2 minutes. So here time is 2 minutes. तो 2 मिनट्स को हम मल्टीप्लाई करेंगे विद 60, तो ये हमारे पास 120 सेकेंड्स आ जाएंगे। तो ये यहाँ तक हमारा केस 1 बनता है। और इसको हम इसमें जो फर्स्ट डिस्टेंस है वो हमने फाइंड आउट करना है। फाइंड द टोटल डिस्टेंस ट्रेवल बाय द ट्रेन। और केस 1 में जो इसका डिस्टेंस बनता है वो हम देख लेते हैं। वी आई मैं ऑलरेडी आपको बता चुका हूँ, 0 मीटर पर सेकेंड है। टाइम टी जो यहाँ पे वो हमें प्रोवाइड कर रहा है वो 2 मिनट्स प्रोवाइड कर रहा है। तो इसको हम सेकेंड में कन्वर्ट करने के लिए 2 को 60 से मल्टीप्लाई करेंगे तो हमारे पास 120 सेकेंड्स आ जाता है। अब यहाँ पे जो फार्मूला हम यूज़ करेंगे वो मैथमेटिकल वे से हम यूज़ करेंगे। तो S1 को हम कंसिडर करते हैं इज इक्वल टू वी एवरेज मल्टीप्लाइड बाई टी। एज वी नो कि डिस्टेंस का फार्मूला क्या है, S इज इक्वल टू वी इंटू टी। बट यहाँ पे हमें वी आई भी दिया हुआ है और वी एफ भी दिया हुआ है, तो हमें एवरेज जो है वो लेनी होगी एंड देन उसको टाइम के साथ मल्टीप्लाई करेंगे। तो ये फार्मूला जब हम इसको लिखेंगे तो हमारे पास बन जाएगा वी एफ प्लस वी आई। टू वेलोसिटीज हैं तो टू के साथ इसको हम डिवाइड कर देंगे, वी एफ प्लस वी आई करके डिवाइड करेंगे टू के साथ और इसको देन फिर मल्टीप्लाई करेंगे हम टाइम जो कि हमें गिवन है 2 मिनट्स और वो कन्वर्टेड है इनटू 120 सेकेंड्स। So we have converted 48 kilometer per hour into meter per second. How we converted it? You can see here, uh, in this 48 was multiplied with 1000 to convert kilometer into meter, and then it was divided with 3600. 3600 came from 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. तो 60 और 60 को मल्टीप्लाई करेंगे तो हमारे पास 3600 आ जाते हैं। उससे इनको हम डिवाइड करेंगे तो हमारे पास जो आंसर आ जाता है वो तकरीबन आ जाता है 13.33 मीटर पर सेकेंड। ये वैल्यू हम पुट करेंगे तो हमारे पास वी एफ की वैल्यू है 13.33 मल्टी प्लस ज़ीरो। वी आई जो है वो हमारे पास ज़ीरो है, डिवाइड करेंगे हम टू से तो हमारे पास वैल्यू आ जाती है 6.67। और इसको हम मल्टीप्लाई कर देते हैं 120 के साथ। तो 120 के साथ मल्टीप्लाई करने से हमारे पास जो वैल्यू आती है S1 की वो आ जाती है नियरली इक्वल टू 800 मीटर। Then the second case in this statement is given that it travels at this speed, the speed which is previously given 48 kilometer per hour, and this speed for 5 minutes. अब ये केस 2 में हमने 5 मिनट्स के साथ जो है वो स्पीड पे डिस्टेंस उसका फाइंड आउट करना है। तो हमारे पास वी एफ जो है वो जो इसकी वेलोसिटी होगी और इसके बाद जो टाइम है वो हमें 5 मिनट्स दिया हुआ है तो इसको कन्वर्ट कर लेंगे हम सेकंड्स में। 5 मल्टीप्लाइड बाय 60 इज इक्वल टू 300 सेकंड्स एंड हेयर S2 विल बी इक्वल टू V into T। And v into t, here we are using just vf because this is the second part, and we have taken previously uh, the value of or the distance covered by the train in last 2 minutes. Now we are moving on towards next 5 minutes. So 13.33, which is the value of vf, we will multiply it with 300, and we will get the value of s2, which will be nearly most nearly equal to 4000 meter. Then finally it moves with uniform retardation. Retardation means that its speed is going to be decreased. So here we will take the value 48 kilometer per hour, which will be converted into meter per second as 13.33 as its initial velocity. In case of in third case, vi will be 13.33, and as it has to be stopped after 3 minutes, so vf will be 0 here, 0 meter per second, and the time will be 3 minutes. 3 minutes will be converted into second, and it will be 180 seconds. So here vi is equal to 13.33 meter per second, and vf is 0 meter per second. Then time t is 3 minutes, which is converted into seconds as 180 seconds. Here we will again use the first formula, which is given as S3 is equal to V average multiplied by T, VI plus VF divided by 2 multiplied by 180. By putting the values, we will get 13.33 divided by 2 multiplied by 180. And when we simplify it, 6.67 multiplied by 180 will be equal to uh, nearly 1200. Now the total distance which we have to find is s is equal to s1 plus s2 and s3. All together we will plus and add up all these distances covered in all three cases, which is 800, then 4000, and then 1200. In the final result, it will be 6000 meter. Now moving on to the next numerical problem, which is 2.8. And here we have the statement: a cricket ball is hit vertically upward. It means it moves and against the gravity. So gravitational acceleration will be in negative, and its value will be -10, and returns to the ground 6 seconds later. Means it's going from the ground to the above at the highest point, and then it comes back to the ground in 6 seconds. Calculate maximum height reached by the ball and initial velocity of the ball. Here this height will be the distance covered by the ball. So for that, let's see what is given. The acceleration due to the gravity, which is g, and its value is -10 meter per second due to the upward motion of the ball, and the time to reach the maximum height at the one side. ठीक है, ये टोटल टाइम यहाँ पे उन्होंने हमें दिया हुआ था 6 seconds. तो from the ground to the maximum height and then coming back to the ground is the total time given for this ball. We will divide it with 2 and we will get 3 seconds. Velocity at maximum height, which is vf, is 0 because at the maximum height the ball after reaching will be stopped, and then it will return back towards the ground. The maximum height reached by the ball is s, and it will be the distance which is being covered by the ball from grounds toward the height. And what we have to find the next is maximum initial velocity of the ball, which is vi. As per the formula from the equation of motion, we know vf is equal to vi plus at. So here a is equal to g. This formula can be written as vf is equal to vi plus gt. अब ये फार्मूला को जब हम कन्वर्ट करते हैं तो इस साइड से जब हम मूव करेंगे जी टी को वी एफ वाली साइड पे इक्वल के अदर साइड पे, तो ये नेगेटिव में चला जाएगा, वी एफ माइनस जी टी फार्मूला में कन्वर्ट हो जाएगा. नाउ हियर वी आर गोइंग टू पुट द वैल्यूज. The value of vf is 0 and the value of g is minus 10, and the time is 3 seconds. So by multiplying with this value, we will get 30 meter per second, and the minus sign is nullified with the minus sign outside this bracket. So next we have to find the maximum height or the distance. So for this we are going to use third equation of motion, which is 2as is equal to vf square vi square. From here, if we move 2a on the other side, so it will divide vf square minus vi square, and here you can see in the formula. And then by putting the values, we will get vf, as we know, is 0, and vi is 30. By squaring 30, we will get 900 and the minus sign along with it. And in the denominator, we have 2 multiplied by minus 10. It will be converted into minus 20. The upper minus sign and the lower minus sign will be nullified with each other, and we will get uh, the answer of 45 meter, जो कि हमारा maximum height traveled by the this ball vertically. So this was all about the 2.8 numerical problem. Now we'll move towards the next numerical problem, which is stated as when brakes are applied, the speed of a train decreases from 96 kilometer per hour to 48 kilometer per hour in 800 meter. So here 800 meter is the distance, and we are given two speeds. One is 96 kilometer per hour and one is 48 kilometer per hour. Here 96 kilometer per hour will be the vi and 48 kilometer per hour will be vf. And how much further will the train move before coming to the rest, assuming the retardation to be constant? So here the vi, which is 96 kilometer per hour, we are going to convert it into uh, meter per second. So as we all already know that for converting it into kilometer into meter, we will multiply 96 with 1000, and to convert r into seconds, we will divide it with 3600. By simplifying, we will get 26.67 meter per second. So here we have the VF final velocity, which is 48 kilometer hour. Again, 48 multiplied by 1000 divided by 3600. And by simplifying, we will get 13.33 meter per second. So here the first distance which is given is 800 meter. We have to find the further distance being covered by this train before coming to the rest. So first we will find the value of acceleration by which it is moving. For that, we will use third equation of motion 2as1. Here we will use an vf square minus vi square. By putting the values, we will get 2a multiplied by 800. It will become 1600a. A is the acceleration, and vf is 13.33 square, and minus vi, which is 26.67 square. After getting the square, we will get the value 177.69 of vf minus 711.29 of the vi. By subtracting this, we will get minus 533.60. Here the minus is missing, but you have to write the minus value here because we are subtracting this from the greater value is with negative sign. In the next step, we will move 1600 from here and divide the value which is remaining by dividing minus 533.60 with 1600. We will get the acceleration of 0.33 meter per second square, and it will be also in negative as the speed of this train is decreasing or retarding. Now we will find the value of further distance S2. Here VF, as we know that train has to stop, and S2 we have to find. Again, the same formula we are going to use, and by putting the value 2 multiplied by minus 0.334, S2 is equal to 0 square and minus 13.33 the square. Uh, by simplifying, we will get minus 0.668 multiplied by S2 is equal to minus 177.69. This 0.668 will go the other side of the equal sign and divide 177.69. The minus sign of both the values will nullify each other, and then the second distance we will get is 266.6 meter, which is our required value. Now, this last numerical problem, which is 2.10, is for this statement is the same as in the 2.9, but what we have to find it, we have to find the time taken by the train to stop after application of the brakes. So for that, what we are going to use this equation of motion. Vf is equal to Vi plus At, and from here we will move Vi to the other side of the equation, and we will get At is equal to Vf minus Vi, and A will go other side of the equation from here to this, and divide Vf minus Vi. Now, by putting the value, we will get the value of time which is required. So 0 minus 26.69 divided by minus 0.334. The minus value will nullify each other, and the time we will get is nearly 80 seconds. So thank you all for watching this video. If you have any query or any questions, you can ask me in the comments, or I'll share with you my contact number. You can discuss with any sort of queries you have regarding your subjects. Thank you. Allah Hafiz.